everyone, welcome back to Data Nutshell. In our first video, we talked about what cloud storage is, why data centers exist, and how redundancy keeps your files safe. Today, we're going a level deeper. We'll explore exactly how your data is stored, organized, and managed on the cloud, and how you can access it instantly from anywhere in the world at any point in time. So let's first see how cloud storage deals with the challenge of storing data at such massive scale. Imagine the scenario that you're running a cloud storage service and millions of people from around the globe are uploading files to your cloud every second. Photos, videos, documents, backups, all are getting dumped at your cloud at the same time at massive scale. So, how do you make sure that each of these files that is getting uploaded to your cloud are stored safely? That users can access their files instantly whenever they want from wherever they want, and how your system has to continue working even if some of your servers fail. So, storing one file is easy, but storing billions of these files and keeping them all fast, all safe, and accessible, that's where engineering gets really interesting. So cloud providers actually solve these kind of problems using a combination of concepts like logical storage, physical storage, redundancy, tiering, and so on. So today we'll get into some of these and understand how this works. So let's first see how files are stored on the cloud. When you upload a file to the cloud, the system doesn't just put your file somewhere on the server. Cloud storage is smarter than that, and it actually uses two layers of organization: logical and physical. Let's see what logical storage means. Logical storage is nothing but like a map for your files. You can go to that map and check where your file is located. So it's not the file itself, it's just some information about your file which tells you where on that actual disk your file's data is located. And it's called the metadata. So, what does metadata include? It includes the name of your file, the size of your file, the type of your file, that is, if it's a photo, video, or a document, the owner's name, and various timestamps linked to the file, that is, the creation time, the modification time, etc. But the most important thing that metadata stores is the actual physical location of your file's data. It tells you where on that physical disk you have to go and locate your data. So we'll take an analogy. Imagine a massive library. If you just dump your books in there, you might never find those again. Instead, you need a catalog system. A librarian in each library maintains a catalog which tells you, okay, that ABC book is located in row number this, shelf number this, and box number this. So, this catalog is a logical storage. It doesn't contain the book itself, it just tells you where to go and find that actual book. Without it, it's very hard finding a books in a library. So, why do we need logical storage? Because physical storage is just blocks on a disk, and each of these blocks stores zeros and ones. And to a layman user or to even most applications, this raw layout of zeros and ones is meaningless. You wouldn't know which of these blocks belongs to which of your files or documents or photos. So, if you try to work directly with physical storage, it would be like opening a random dump of binary numbers. That's where logical storage comes into picture. Logical storage adds that software layer on top of that physical storage. It's a map which blocks those zeros and ones to your files and folders. It tells you which block of data belongs to which file. So it maps those raw blocks into files, folders, and volumes so humans and applications can actually understand and make meaning of that data and use it. So logical storage makes your data usable. So physical storage is the actual warehouse. Now, once the catalog says store this file, the actual bytes need to go somewhere. That's physical storage, the real hardware, the disks, the SSDs, the storage arrays, the servers, the actual physical place where your data is written. But here's the catch: your file usually isn't stored as one big piece. Instead, cloud providers break your files into smaller chunks, and each of these chunks is stored on different servers on different disks. Why is it done? To ensure speed. Because if chunks are available on multiple parallel servers, those chunks can be read in parallel using those multiple servers, and it makes access to your files much faster. It also makes it reliable because if one of those chunks is corrupted, you just need to go and replicate only that one chunk, and rest of the chunks of your data is safe. It makes it scalable because chunks are distributed across thousands of servers, and those thousands of servers are huge storage pools. So, when you upload a photo to the cloud, logical storage creates a catalog entry with details about your file. Physical storage splits it into chunks and distribute those chunks across servers, across disks. The catalog records exactly where to find which chunk of your data. Later, when you open that photo, the system checks the catalog. The catalog tells the system which chunk belongs to which disk, and those chunks are reassembled and the photo is shown to you in milliseconds. Without logical storage, your file would be lost in a chaos, and without physical storage, there will be nothing to retrieve, there will be no actual data. Together, they make cloud storage organized, reliable, and fast.